All right, so we've dealt with double angles, well, the sine or cosine tangent of 2x. We've dealt with having angles squared, sine squared of x, and how we can reduce that. Now we're going to deal with half angles, so an angle divided by 2, so tangent of theta over 2. And we have the formulas that are on our sheet. The half angle formulas are numbers 38 through 42. So what we'll do is find the exact values of the trig functions using our half angle formulas. So 7 squared plus 24 squared equals c squared. Well, this is a Pythagorean triple, but you get 625 equals c squared. So 25 is equal to c. So now we can calculate the sine, cosine, and tangent of our angle since we have the sides. So the tangent of theta over 2, if we look at our formula, we actually have a few options. We can do plus or minus the square root of 1 minus cosine over 1 plus cosine. We can do 1 minus cosine over sine, or we can do sine over 1 plus cosine. It doesn't matter which one we choose to do. I'm going to do the 1 minus cosine. So 1 minus cosine theta over sine theta. So we get 1 minus cosine is the adjacent over the hypotenuse, so 7 over 25 over sine is 24 over 25. So I'm going to multiply the top and bottom by 25. The top and bottom of the big fraction. So I'm going to multiply this by 25 and this by 25. And I can do that because I have that big fraction, and as long as I multiply the top and bottom by the same thing, everything will be okay. So distribute this. It's actually going to be 25 minus 25 times 7 over 25. The 25s would cancel. So we have 25 minus 7 over the 25s would cancel here as well, and we get 24. So we get 18 over 24, which simplifies to 3 over 4. And that would be the tangent of theta over 2. And again, we couldn't just find the tangent of theta, the opposite over adjacent, 24 over 7, and divide that by 2. That's not going to give us the same thing. So it wasn't that bad. For once, tangent was a little bit easier to deal with. Then letter B, the cosecant of theta over 2. Well, we know that cosecant is the reciprocal of sine. So I'm going to take the sine one and flip it. So this is equal to the square root of 2 over 1 minus cosine of theta. That's using the sine formula, but flipped. So we have the square root of 2 over 1 minus, and the cosine we already figured out over here was 7 over 25. Now again, we don't want that fraction in the denominator, so if I multiply the top and bottom by 25, if I multiply this by 25 and this by 25, it's going to just reduce it down to a single fraction, which we can hopefully manage a little bit better. So then we get the square root of 50 over 25 minus 7, which is equal to the square root of 50 over 25 minus 7 is 18. This reduces to 25 over 9. Oh, we can take the square root of both of those. 25, the square root of that is 5, and the square root of 9 is 3. So that's our answer. We didn't have to rationalize the denominator because the denominator ended up being a perfect square. So this is what we would do if we had a triangle and we had all the sides. Using the formula isn't too bad. Again, just your algebra skills. Now, example 2, we're going to use these half angle formulas to determine the exact value of sine, cosine, and tangent of 112 degrees and 30 seconds and pi over 12. So if we look at 112 degrees 30 seconds, first we want to know that realize that this is in quadrant 2, where cosine is negative, sine is positive, and tangent's negative. So when we look at our half angle formulas, we'll have an idea, we'll know if we should use the plus or minus part of those formulas on our sheet. So then what we'll need to do is figure out how can we change 112 degrees and 30 seconds into an angle that we can use in this formula. Well, 30 seconds, there are 60 seconds in a minute, so 30 is half of that. So this is really 112.5 degrees. And if we were to multiply this by 2, and that's a clue to some of these questions, is that if we say use the half angle formula, or say something about half angle along the lines, we're going to give you something that's either a triangle like this, or something that's make it so that we can use the unit circle. If we multiply this by 2, we get 225 degrees, which is on the unit circle. So we're going to use that for theta in our formulas. So the sine of 112 degrees and 30 seconds is going to be equal to the sine of 225 over 2. Okay. So when we use our formulas and we see theta, we're going to use 225 degrees because half of that is 112.5, which is 112 degrees and 30 seconds. So then when we write the sine formula, the half angle, it's the square root of 1 minus the cosine of theta, which is 225 degrees. Theta is not the angle that we are trying to find the sine of. Theta is the angle that we're using to help us find the sine of 112.5 degrees. So then the cosine of 225 degrees, so is negative square root of 2 over 2. Now, just like we did above, we're going to multiply the top and bottom of the big fraction by 2. And that's going to give us the square root of 2 plus the square root of 2 over 4, because we have minus minus right here. Well, we can't take the square root of the numerator, so that's just going to stay the square root of 2 plus the square root of 2 over the square root of 4, which is 2. So that is the exact value of the sine of 112.5 degrees, or 112 degrees and 30 seconds. That's our exact value. And we used the fact that the square that 225 degrees is on the unit circle. So now cosine. Cosine of 225 degrees over 2. And because our angle is in quadrant 2, cosine is negative, so we're going to use the negative formula. So this is going to be, let's do it down here, negative square root of 1 plus cosine of 225 degrees over 2. So equals negative square root of 1 plus negative square root of 2 over 2, because that's what the cosine of 225 is, over 2. Multiply the top and bottom by 2. And I know you could have just looked at the above work and said, oh, I just know that some of the signs are going to change, but it's good to let us practice this, because maybe a problem, I'm only asking for cosine, so now we need to make sure we know how to use the cosine half angle function. So 2 minus the square root of 2 over 4, negative out front, so then it equals negative square root of 2 minus the square root of 2 over 4. And that would be what the cosine of 112 degrees 30 seconds would equal. Now for tangent, again, we have choices. I would not really want to use the square root one. That just makes things a little bit more complicated. So the tangent of 225 degrees over 2, I'm going to use the 1 minus cosine one again. So 1 minus the cosine of 225 degrees over the sine of 225 degrees. So that gives us 1 minus negative square root of 2 over 2 over negative square root of 2 over 2. So I'm going to multiply the top and bottom by 2 like we've been doing. And that's going to give us 2 minus the square root of 2 over this, negative square root of 2. Well, we can't have the square root of 2 in the denominator, so we're going to multiply the top and bottom by the square root of 2 over the square root of 2. And it FOILs into the numerator. So that's going to be 2 times the square root of 2 minus 2 over negative 2. Oh, whoops, I'm sorry. Minus minus should be a plus right here. Plus. So this should be a plus. So now I can reduce everything by negative 2. So that's going to give us negative square root of 2 minus 1 as our final answer, because I'm dividing everything by negative 2 here. And we don't need to write the 1 in the denominator. So that would be our tangent of 112 degrees 30 seconds. All right, now using pi radians, we have pi over 12. So again, pi over 12, this is in quadrant 1, where everything is positive. So we won't have to worry about any of the negative signs or the plus or minuses for the halving and the half angle formulas. Whoops, plus. So pi over 12 is really pi over 6 divided by 2 or multiplied by 1/2. So our theta, if we have pi over 12 times 2, that's 2 pi over 12, or pi over 6. So our theta in these problems is going to be pi over 6, because pi over 6 divided by 2 is equal to pi over 12. So the sine of pi over 12 which is equal to the sine of pi over 6 divided by 2 is equal to the sine formula. We're in quadrant 1, so we need to worry about the positives. The square root of 1 minus the cosine of pi over 6 over 2. Well, the cosine of pi over 6 is the square root of 3 over 2. So then we're going to multiply the top and bottom by 2. So then this is going to equal the square root of 2 minus the square root of 3 over the 4. And we can square root only the denominator, so it's going to be the square root of 2 minus the square root of 3 over the square root of 2, which is 4. So that's going to be our cosine. sorry, that's going to be our sine of pi over 12. Then cosine of pi over 12 is equal to the cosine of pi over 6 divided by 2. So it's going to be the square root of 1 plus cosine of pi over 6 over 2. And again, since we're in quadrant 1, we don't need to worry about a negative in front. So then this equals the square root, whoops, let me make a big square root, 1 plus the square root of 3 over 2, all over 2. Multiply the top and bottom by 2. So then we get the square root of 2 plus the square root of 3 over 4. And again, we can only square root the bottom. So it's the same thing in this case as the sine one, except we have a positive inside 2 plus the square root of 3 instead of 2 minus the square root of 3. All right, then finally tangent. The tangent of pi over 12 is equal to the tangent of pi over 6 over 2. So 1 minus the cosine of pi over 6 over the sine of pi over 6. So we have 1 minus the square root of 3 over 2 over 1/2. Now again, I could have used any of the tangent half angle functions, but I knew that the sine of pi over 6 was 1/2, and it's easier to deal with a 1/2 in the denominator than if I would have used sine over 1 plus cosine. Well, now I have the square root of 3 over 2 in the denominator, and I just didn't want to deal with that. So we'll multiply the top by 2 and the bottom by 2. And that gives us 2 minus the square root of 3 over 1. 1/2 times 2 is 1. So this is just going to equal 2 minus the square root of 3. So the tangent one, it seems to be a little bit simpler or less tedious than the sine and cosine ones. So again, we have to make sure our algebra skills are sharp and we're not doing anything algebraically illegal. All right, now on the next page, we're going to be kind of going back and using that triangle again, okay, because I'm giving you some side lengths, but the difference here is that we have a quadrant that the angle's in, which is going to change our positive or negative values for sine and cosine, which means we would use different measurements depending on different formulas depending on the quadrant. So before we do anything, we want to figure out what angle U is in, what quadrant angle U is in, so we can figure out the missing side length, and then figure out what quadrant U over 2 is in, because that's what we're trying to really figure out. We're trying to figure out sine of U over 2, cosine of U over 2, and tangent of U over 2. So our final answers should be dependent on what quadrant U over 2 is in. So first let's get this triangle figured out. Theta, sine is opposite over hypotenuse, and if U is between 3 pi over 2 and 2 pi, this is in quadrant 4, where cosine is positive. So let's do 5, whoops, let me give us a little room. 5 squared plus x squared equals 13 squared. That's 25 plus x squared equals 169. X squared equals 144. And x is 12. If you recognize that this is a Pythagorean triple, then that's fine. And I'm going to be blunt with you guys. Most of the time for problems like these where you're going to be having square roots anyway because of the half angle formula, chances are the information given to you is going to be a Pythagorean triple, so that we don't so that way you don't have a lot of square roots in your simplification. Now, I'm not saying that's always the case, but I'm saying it's a good chance that it will be a Pythagorean triple. So we need to figure out what quad u over 2 is in. So we were originally given that 3 pi over 2 is less than u, which is less than 2 pi. Well, we want to know about u over 2. So if we divide everything by 2, dividing by 2 is the same as 1/2, multiplying by 1/2. So we have 3 pi over 4 is less than u over 2, which is less than pi. So this angle is in between 3 pi over 4, which is in quadrant 2, and pi, which is the end of quadrant 2. So this is in u over 2 is in Q2. We have negative, positive, and then negative for tangent. So now that we have that information here, let's go ahead and figure out the sine, cosine, and tangent of this angle u over 2. So the sine of u over 2 is equal to the square root of 1 minus cosine of u over 2. And again, we're not using the negative in front because our angle u2 or u over 2 is in quadrant 2 where sine is positive. So then this equals the square root of 1 minus, okay, so minus the cosine of u over here. Cosine is the adjacent over hypotenuse, so 12 over 13 over 2. We're going to multiply the top and bottom by 13. This will give us 13 minus 12 over 26. Again, we're distributing. So then we get the square root of 1 over 26. Well, we know we can't have the square root in the denominator, so multiply the top and bottom by the square root of 26. So we get the square root of 26 over 26. So at some point in this lesson, we're not going to write how we're rationalizing the denominator. You just need to know, oh, we need to rationalize it, multiply the top and bottom by the square root of 26, and this is what we get. So the sine of u over 2 is positive square root of 26 over 26. Now the cosine of u over 2 is equal to negative square root of 1 plus cosine of u over 2. And again, we're using the negative in front because we are in our angles in quadrant 2 where cosine is negative. So then this is equal to the square root of 1 plus 12 over 13 because that's the cosine of u over 2. Multiply the top and bottom by 13 again. This will get us the square root of 13 plus 12 over 26. Last time I checked, 13 plus 12 is 25. Oh, I forgot my negatives in front, I'm sorry. The square root of 25 is 5, so this is equal to negative 5 over the square root of 26. And we can't have a negative in the square root, so we can't have a square root in the denominator. So multiply the top and bottom by the square root of 26, and we get negative 5 times the square root of 26 over 26 as our cosine. Finally, tangent. Tangent of u over 2 is equal to 1 minus the cosine of u over the sine of u. Well, we already know that the cosine of u is 12 over 13. We've been using that. The sine is the opposite over hypotenuse, and actually we're given it right here. Sine is negative 5 over 13. So then multiply the top and bottom by 13. We get 13 minus 12 over negative 5. 13 minus 12 is 1 over negative 5, which is negative 1/5. And that would be our tangent of this u over 2 angle. All right, our last example, example 4. Thankfully, we're just finding one of the angles and not like 3 for each one, because that's a lot of work finding sine, cosine, and tangent for each one of these. So this one is just finding cosine of u over 2 when tangent of u is 7 over 24, and pi is less than u, which is less than 3 pi over 2. So this means that our angle is between pi and 3 pi over 2. So u is in quadrant 3, because that's between pi and 3 pi over 2. So when I draw my triangle here, tangent is opposite over adjacent, and 7 squared plus 24 squared equals c squared. 625 equals c squared. This is another Pythagorean triple. But we have to realize that in quadrant 3, sine and cosine are negative. So the cosine of u is actually negative 24 over 25, and the sine of u would be negative 7 over 24. It didn't affect us really in this problem because cosine was positive in quadrant 4. It did affect us a little bit for tangent, but they told us tangent was negative, sine was negative right here. So we did sine of u, we already knew it was negative. So we had to be mindful that u over 2 and u both factor into this problem, into all of these problems. So the cosine of, first we got to figure out, what quadrant is u over 2 in? So we have pi is less than u, which is less than 3 pi over 2. Divide everything by 2. So that means pi over 2 is less than u over 2, which is less than 3 pi over 4. So pi over 2 is the start of quadrant 2 and the end of quadrant 1, and 3 pi over 4 is in quadrant 2. So we are in quadrant 2, where cosine's negative, sine is positive, and tangent is negative. So cosine of u over 2 equals, well, because we are in quadrant 2, where cosine is negative, we're going to use the negative sign in front. So negative square root of 1 plus cosine of u over 2. Now the cosine of u. The cosine of u is negative 24 over 25 because u is in quadrant 3 where cosine is negative. Oops. So then, multiply the top and bottom by 25. So we get negative square root of 25 minus 24 over 50. This is equal negative square root of 1 over 50. We can simplify the square root of 50 into 5 root 2. So we're going to do that. So negative 1 over 5 times the square root of 2. Can't have the square root of 2 in the denominator, so negative square root of 2 over 5 times 2, which is negative square root of 2 over 10. And that's our final answer. Yeah, so again, this is probably the most complicated stuff we've done so far in this section because there's so many small nuances that we have to be mindful of. We have to be mindful of, what quadrant is u in? What quadrant is u divided by 2 in? Do we have radicals that we have to worry about? Can we take square roots? Like, there's a lot of small things that we have to take it into consideration aside from using the formula. Okay? So more practice on this will definitely help us get better at this and being more mindful of what we need to worry about. So thanks for watching. Make sure to like the video and subscribe.